My name is Harley Nishat, and this is FFE Inc.'s report on our NASA Mars rover. This presentation is going to include a summary of our manufacturing activity, a summary of all of our test results, including images and videos, and also the redesign process as well. My name is Harley Nishat, and I was the project manager. Darylson Fontaine was our test and software engineer. Sheldon Eason was our manufacturing lead, and Lamar Thompson was our other manufacturing lead.
So on our NASA Mars rover, we were required to have it achieve line tracking, obstacle avoidance, and also Bluetooth control. But we were unable to achieve Bluetooth control because there were technical difficulties involving the app, and also unable to achieve line tracking because of it being backwards instead of it facing forward. Also, what we could have done better on was better placement of screws on the motors, attaching the 4 motors to the board correctly, have the line tracking sensor facing the right direction, and also the use of screw sizes, spacers, and making sure things were tightened. Because whenever it came down to our rover moving around, some pieces would begin to fall apart.
Mars rover project. Overall, the design of this machine was not necessarily the hardest, but with every design comes its challenges and its flaws. During the design of the Mars rover project, the most unparalleled problem that the team ran into was with the screws that were in the design box. There were many different size screws that even at one point the group got stumped. All pieces were poured out at once on the table, which proved to be a grave mistake as pieces became undistinguishable. There were times putting the robot together that the group did not know quite which piece went where, and as a result of that, pieces seemed missing. At first, the missing components did not seem to phase the group and actually allowed the group to improvise in putting the pieces where they needed to go. But unfortunately, the team learned the hard way that you cannot alter where pieces need to go. And because of that, the design started to fall apart. But all in all, the team came to the understanding of the meaning that you have to deal with the hand that you're dealt. And for some recommended changes, we would go slower next time. We would take the design step by step and use pieces as needed. We would take inventory, analyze the instructions better, and not dump out our pieces altogether. And this is our DD250 worksheet.
What you're looking at right here is the image for the DD250 test results. As you can see, our rover passed every test. After our project manager, Harley, went back and looked over it, we spoke about what went wrong and understood the fixes that she made. We got a 5 with the easy line tracking test, and a 5 with the medium, and a 10 with the difficult test. A 10 with the obstacle avoidance, and a 10 with the Bluetooth control. These are the line tracking videos. The first video on the left is the first video where the line tracking was backwards. And then the second video is where you can see that we fixed it, but it jerks a little bit because it jerks a little bit, but that wasn't really an issue because it still went on the line. During the line tracking results, the rover moved along the hardest line challenge with ease. It stayed on the track the whole test, and it did not stop to recalibrate itself onto the line. The robot could have been moved along the lines a little bit smoother without the little slight jerks that it had. This is our obstacle avoidance test, and also the Bluetooth control test. The obstacle avoidance test with our rover is successfully seized before hitting an object, then turned to avoid moving into it. The rover could not detect some things such as chairs because the legs were too thin. So that was a setback in the classroom that we had to overcome. So we used a trash can. The rover took about 4 seconds to move away and turn from the object that it detected that was right in front of it. And that was also a slight setback. The Bluetooth control test results. The rover passed the Bluetooth control test results with flying colors with a strong and stable connection. The Bluetooth did not work the first time because the app updated on the App Store. So the connection was not really stable at that time. The rework and design activities. Many different files were uploaded, such as the different testing files that will test the forward, backwards, left, and right wheel turning movements. The different testing files were uploaded to test the movement of the wheels and the brain of the rover. The other files were uploaded to code the rover into doing a specific task, such as the Bluetooth, obstacle avoidance, and line tracking. At first, the illegal app updated and it was not connecting to our robot for the Bluetooth test. The different coding files deleted themselves off of the laptop the first time because the software also updated. So we had to re-upload the software.
Overall, I think that our rover was a success. However, during the assembly of the rover the first time, we learned that when manufacturing, it is very crucial to work as a team. Our team meant well when we split up the manufacturing tasks because we were trying to save time. However, that did not allow us to pay attention to detail and stay organized. I think that the organization is the main cause of all of the problems that the rover had. So the second time when I assembled it, I made sure to pay attention to detail, such as the direction of the line tracking sensor, the direction of the screws on the motors, and that allowed the rover to complete the test successfully. It was timely and tedious, but once again, all of our test results were successful. We met all of our customer requirements.
Okay, what went wrong with our rover was like the screw sizes. If we paid more attention to them, we could have actually accomplished what we needed to on the rover, because what we had done at first, whenever it came to movement to the rover, it would begin to rattle. That's why we couldn't really get it to stay on the line, so it didn't really have line tracking. So yeah, we should have just did better on the screw sizes on attaching them.
Yeah, and when I went and disassembled it after class, I did find the missing screws that we placed in the motor that were supposed to be used for the chassis. And Sheldon was missing them, so we tried to improvise because we were also limited on time. And I think that the misplacement of those screws is really what messed up the entire design of the
Yeah, just to
rover.
piggyback off that, essentially just the misplacement of everything, as well as the putting of wrong screws and spaces and all that in the wrong places, just really messed up the whole design, including the line tracking and all that, which ultimately, messed up everything.
Overall, this rover project was a great addition to us being in first year engineering. And we do feel as if we learned how to work together as a team. And we managed to talk to each other and make some adjustments to either the report, our rover, or maybe even helping each other looking for the different pieces while the other one is looking at the instructions. And also, this project will be able to help us with our note taking, because we had to write down all of the little parts that we needed. And we basically looked through the boxes of the kit to make sure we had every piece. But some pieces were missing, and we seen that and we tried to improvise. But all in all, this project was a great project, and it will lead us to a bigger project once we get into the fall semester or later in the year.
I agree with what Darrelson said. And even though when we were testing in class, our rover literally started to fall apart, but we were working as a team and we were trying to figure out what was wrong, and everyone had a part in trying to fix it. And I think that was just overall a really great experience for everyone to learn to work in a group because we had never met each other until this project.
Yeah, just to piggyback off what she said, basically we had a lot of setbacks in our design, but like she said, we came together and we really somewhat overcame the obstacles that were thrown at us.
Yeah, so I agree with Darrelson. We did learn a lot from this project for us being in our first year for engineering. It taught us some pros and cons. Taught us what, like what he said, note taking. It really helped us with a lot of things.